We are still in 4.2, so I'll go ahead and write that at the top. This is just 4.2, day 2. So we are still working with rational functions. So rational functions, okay? And today we're going to look at some that have some special cases. So we're going to explore some with that have holes. So the graph to the right shows the function. So this graph right here is showing g of x equals x minus 1, all divided by x minus 1 times x plus 2. So the first thing we're going to do is just look at the graph over here and see what we can see at x equals 1. So here, I'm just going to highlight where x is 1. So anywhere on this line right here would be x equals 1. And if you look, there is an open circle right there, and that is called a hole. So what do we notice? There's a hole on the graph. Okay, and let's see. The next part, it says, what do you notice about the equation when x equals 1? So let's plug it in and just see kind of what happens. So what we're going to do is we're going to plug in x equals 1 into all of our x values. So we're going to look at, whoops, didn't change yet. Here we go. G of 1, which equals the 1 minus 1, and then all over 1 minus 1 in parentheses, and then we would do 1 plus 2. So when we do that, we have 1 minus 1 is 0. Well, anytime we have 0 of nothing, then we have nothing, right? We have 0. However, we also have a 0 on the bottom times 3. And we have already learned that we cannot divide by 0. So this is an undefined answer. Okay. Let's keep going though. Let's look at some more things about this function here. So it says, write a simplified equation for g of x. Well, let's think about something. Let's just go over here and kind of play around with something. So if we had 2 times 3 divided by 2 times 4. Well, if we had this, we would say, okay, well, 2 and 2 is just going to be 1. So this is really 1 times the 3 over 4. So it would be just 3 over 4. Well, it's the same idea over here. So right now our function looks like g of x equals x minus 1 all over x minus 1, x plus 2. So right here, these two are the same, x minus 1 and x minus 1. So when they divide each other, they're just equal to 1. So we don't actually need them there. So simplified, g of x is actually equal to 1 over x plus 2. Now, when we look at this function, it's kind of misleading because we saw that in our graph, x cannot equal 1. And then here, it also can't equal negative 2. Now, when we're writing this, we're not just going to say x cannot equal 1. We're going to say there is a hole at 1. There is a hole at x equals 1. Okay, so now let's look at another one. It looks very similar to the one we just did. However, the x plus 2 is on the top now. So let's see how that changes it. So what do we notice when the graph x equals 1? Well, there's a hole again, right? So there's a hole at x equals 1. There is a hole at x equals 1. What do we know about the equation? Let's plug it in again and see what we see. So again, we're doing g of 1. So we're going to plug in 1 for every x value. So that's going to look like 1 minus 1 all over 1 plus 2, and then 1 minus 1. So now we have 0 times 3 on the top, and then 1 minus 1 is 0. So it's still undefined because we can't divide by 0. However, this time it looks a little different. So now let's write a simplified one just like before. So again, our function right now is g of x equals x minus 1, x plus 2, and x minus 1 on the bottom. So find your duplicates, one on the top, one on the bottom, right there. Those sum, or not sum, but they equal 1, so we don't actually need them. So we can rewrite g of x as x plus 2. And then we need to state that there is a whole at x equals 1. Okay. Oops. And that is the end of 4.2 day 2. Thanks for watching.